Unit Operation Classroom. Today we are discussing bond law power requirement for coal crushing. My name is Shekhar Bhattacharya. The gross energy requirement to reduce a very large feed of coal that to such a size that 80% of the product passes through 100 micron screen is 13 kilowatt hour per ton of heat. This part that came from here that reduce a very large feed of coal to such a size that 80% of the product passes through 100 micron screen. This is just a definition of a bond work index, which we will see later. This is not related to the feed or product sizes. So we'll see how this portion is accounted for in bonds law. In a process, now we are talking of the actual process. 250 tons per hour of coal is crushed. The range of feed size is such that 80% of the feed passes through an opening of 100 mm. That's a very standard way of expressing the feed size for Bond's law. And the product size range is to such that 80% of the product passes through an opening of 25 mm. So this is for the feed and this is for the product. According to the Bond's law, which one of the following is the power consumption? So the Bond's law is given by this equation right here, and we will see what means what. P is the power requirement for what we will see. M dot is the feed rate. So this is 250 tons per hour, which is given right here. This is 250 tons per hour of coal is crushed. Now we have WI. What is WI? W is the bond work index. This is given in kilowatt hour per ton. This is the range of energy. So this is given for this problem is 13 kilowatt hour per ton. This is the gross energy required to reduce kilowatt per ton of heat to reduce a very large feed to a product size such that 80% passes to 100 micron scale. So this is basically a definition to evaluate the value of WI, and this is just a property of the material itself, not much of the equipment. This is a property of material. We'll see that. So bond work index WI is primarily a measure of the resistance of the material to size reduction. Okay, so and that's a very standard way of measuring it. And next we only have DP and DF. Okay, DP is the feed size, which is 100 millimeter given, and DP is the product size, which is 25 mm given. Next part is just a very simple calculation, and we'll see D is the correct option. So one important thing to see is that 100 micron is used only to define WI. So this 100 micron thing, what we are discussing here, that product 80% product passes to 100 micron speed is this. So this is just to define the WI, which is right here. So the answer is E is equal to 0.02.765, and B is the correct option. Note if 100 micron is used only to define WI. For the actual process, feed and product sizes are 100 mm and 25 mm respectively. Practical application of this problem. Many chemical plants use coal for steam generation, that is used for process heating, evaporation, and drying. It's also used for coal. It's used for coal gasification process, which where we get the syngas and which is used for ammonia, methanol, and hydrogen. Uh, so what happens is we take the raw coal and it goes to a primary crusher, which basically reduces its size from very large to around 100 to 150 millimeter. Then it goes to a secondary crusher, something like a double road crusher, tooth road crusher, around 100 mm to 25 mm. And this is finally sent to a gasifier feed preparation unit, which is basically what it does. It converts 70 to 80%, goes to 75 micron. And this is basically a pulverizer, such as like a ball mill. Um, so this problem represents a secondary coal crushing operation. Bond's law is used in coal handling sections of chemical plants to estimate power required for crushing coal from very large lumps to specific product size, where we use the Bond's law. This is also important for crusher selection, motor sizing, energy cost estimation, and reliable feed preparations for boilers, gasifiers, and pulverizers. So finally, the answer is this is the correct answer. D is the correct option, 102.765 kilowatt.
Finally, this is just a 3D diagram of a double tooth roll crusher, which is used as a secondary crusher in a coal preparation unit.